Hello everyone, I welcome you all to this class of soft computing techniques. This is the third lecture of module 2. Till now, we have covered module 1 and in module 2, we have covered Cripps relations and fuzzy relations, extension principle, fuzzy arithmetic numbers and operations. In this class, we will try to understand fuzzy multi-valued logic and fuzzy implications. So first one is fuzzy multi-valued logic. So we have studied logic in Boolean algebra. We have studied A, B, A and B. So here is value is either 0 or 1. So you may write it like that. This is 0, 0, 0, 1. It is A and B. So similar things is there, but the value is something, truth value, you can, if we say it is TA, the truth value is something, lies belongs to truth values TA, lies belongs to 0 to 1. In Boolean algebra, it is either 0 or 1. Here is truth value of A, just like a membership value, it lies belongs to 0 and 1. So that is the concept of fuzzy multi-valued logic. Let's try to understand some symbols. So these symbols meaning is not, the notation you can write it not P, and definition is 1 minus TP. TP is the truth value of P. Similarly, this is written as OR. The meaning is P or Q. So that is maximum of TP and TQ. So next is AND. So meaning is it's AND. You can write it P or Q. That is minimum of TP, TQ. Next is that this is known as implication. So written as P imply Q or negative P or Q. So that is maximum of 1 minus TP and TQ. Next is that equal to. So that is meaning is equality. So that is P equal to Q or P imply Q and Q imply P. So the definition is 1 minus absolute value of TP and TQ. So let's try to understand this concept by fuzzy multi-valued logic. So let's try to understand the concept of fuzzy multi-valued logic by the truth table. So truth table, first to write the two variable, that is fuzzy set A, B, and first to write that or, next is and, not A, that is the implications, if A then B, and that is the equality. So write any value, suppose 0, 0, 0, here is we are writing 1/3, 1/3, 1/3, then you write 1, 1, 1. P is 0, 1/3, 1, 0, 1/3, 1, 0, 1/3, 1. So that is A or B. So maximum value. So that is 0, this is 1/3, this is 1, this is 1/3, this is 1/3, this is 1, this is 1, this is 1, this is 1. Now it is AND. So the minimum. So this is 0, this is 0, this is 0, this is 0, this is 1/3, this is 1/3, this is 0, this is 1/3, this is 1. Next is not A. So 1 minus TA. So that is 1, 1, 1, 2 third, 2 third, 2 third. This is 0, 0, 0. Now A imply B. So this is A imply B. So the meaning is not A, maximum B. So not A, B. So not A is 1, maximum is 1, maximum of 1 and 1 third is 1, 1 and 1 is 1, 2 third and 0 is 2 third, 2 third and 1 third is 2 third, 2 third and 1 is 1, then maximum 0 and 0 is 0, 0 and 1 third is 1 third, 0 and 1 is 1. So that is A imply B. Next is A equal to B. So that is basically A equal to B. You can write it 1 minus absolute value of Tp minus Tq. So first one is Tp and Tq. Value is 0, minus 0 is 0. So 1 minus 0 is 1. 0 minus 1 third is 1 third. That is 2 third. This is again 0. This is again 1 third minus 1 minus 1 third is 2 third. This is 0, so 1. This is 2 third, so 1 minus 2 third is 1 third. This is basically 1, so this is 0. This is difference is 1 minus 1 is 2 third, so it is again 1 third. And here it is 1. So you can try these things by taking any truth values of A and B. So next one is that fuzzy implication. So next one is try to understand the same concept by using one example. So example is that let Mr. M is a hardworking person. Is a hardworking person. So hardworking person is a fuzzy set. So assume that the truth value of Tm is 0.8. Next is that Mr. N is a hardworking person. Mr. N is a hardworking person with truth value Tn equal to 0.85. Mr. M is not a hardworking person. Not a hardworking person. So that is 1 minus Tm, that is 0.2. Next is that Mr. M is a hardworking person. Hardworking person, and so is Mr. N. So that is basically M intersection N. So that is minimum of Tm Tn. So that is basically 1. That is basically the minimum value of 0.8 and 0.85. So 0.8. Next is that either Mr. M or Mr. N is hardworking person, is a hardworking person. So that is M or N, so that is maximum of 0.8, 0.85, so that is 0.85. Next is that if Mr. M is hardworking, then So is Mr. N. Please try to understand this type of statement we face in our daily life. In usually we say that if I have a time, I will go there. If I have money, I will purchase this. So here, this A and B are two linguistic variables defined by fuzzy sets A and B on the universe of discourses X and Y respectively. Here, X is A called antecedent or premise, while B is called consequence and conclusion. So, if I write if X is A, then Y is B. So, this A is known as antecedent and B is known as consequence. B is known as consequence. So some examples are if pressure is high then temperature is low. If certain color of fruit, suppose mango is yellow then mango is sweet. If this fuzzy implication is denoted as R, A imply B. It represents a binary fuzzy relation R on the product of A cross B. So in general R A imply B can be written as the fuzzy Cartesian product A cross B. You know how to find that. So which P and T are two universes of discourses representing pressure and temperature respectively as follows. So for pressure 1, 2, 3, 4. For temperature 10. Temperature is 10, 15, 20, 25, 30, 35, 40, 45, 50. That unit is degree centigrade. So the linguistic variables high temperature and low pressure are often as high temperature. So as temperature increases, membership value increases. So that is 0.2, 0.4, 0.6 for 30, for 35, 0.6, 40, 0.7, 45, 0.8, 50, 0.8. So pressure low. So as it is the increased value, membership value decreases. So 1, 0.8, 2, 0.8, 3, now, then the fuzzy implication of temperature is high, then pressure is low can be defined as the relation R T high imply P low. So that is the Cartesian product A cross B. You know the row you can write the temperature, in column you can write the pressure. So here in row temperature, here is temperature, in row you can write the temperature, in pressure you can write it column. Now take the minimum value. So that is 0.2, 20 and 0.2, 0.2. So these are the Cartesian product A cross B. So R A imply B can be written as A cross B. So in general, there are two ways to interpret the fuzzy rule A imply B as A coupled with B, A entails B. So interpretation as A coupled with B or A imply B is A product Cartesian product B. So universe, this is the symbol. So try to understand that integration symbol is that. So you have seen the fuzzy notation for discrete case. This is mu AX by X. So that is the for discrete case. For the continuous variable, you can write at integration of mu x by x, the notation, or simply you can write integrations mu ax. So these are the for continuous case, for continuous fuzzy variables or element xy and inverse discourse of x cross y, where star is called the T norm operator. So T norm operator, the most frequently used T norm operator are minimum, so T minimum AB, so minimum of membership value of A and B, so that is A and B. Algebraic product TAP AB is A into B. Bounded product TBP AB is the maximum value of 0 and so maximum value of 0 A plus B minus 1. Next one is that drastic product TDP. So if B equal to 1 value is A, if A equal to 1 value is B, if otherwise 0 to 1 the value of AB less than 1 then we get 0. For all these case we took A is mu X, B is mu By, T-norm operator. Based on the above T-norm operator as defined above, we can automatically define the fuzzy rule RAB as a fuzzy set with two-dimensional membership functions mu r xy, f of mu x, mu by. We are writing it f ab. A means mu ax, b means mu by. So minimum operator RAB x cross y, mu ax and mu by. So that is the minimum of AB. So that we can say this is given by Mamdani, so that is known as Mamdani rule. Please try to several times we'll use the word Mamdani in fuzzy sets. So that is minimum of A and B. Similarly, algebraic product RAP A cross B is the simply product of mu AX into mu BY. So that is known as the Larsen rule. Next is that bounded operator. So RBPAB. So that is the you can write the maximum value of F bounded product. That is the maximum value of 0 and A plus B minus 1. Drastic product operator RDP. So if B equal to 1 that is A. If A equal to 1 B 0 otherwise. Now try to understand the concept of interpretation of A entails B. So there are three main ways to interpret such implication. First one is material implication. R A imply B. So that is the maximum value of 1 minus mu AX and mu BY. Next is propositional calculus. RAB is the maximum value of 1 minus mu AX and minimum of mu AX mu BY. So first to find the minimum value of mu A and mu B, then we took the maximum value of with 1 minus mu X. Extended propositional calculus is RAB is first to find the intersection of A complement B complement, then take union with B. Interpretation of A entails B. With the above mentioned implications, there are a number of fuzzy implication functions and we are popularly followed in fuzzy rule-based system. So ZA arithmetic rule RZA is equal to A complement union B. So that is the FZ equal to minimum of 1 and 1 minus B plus B. So minimum of and 1 minus A plus B. Then ZA max min rule, so that is RMM AB is maximum of 1 minus A and minimum of A and B. So that you can write maximum of 1 minus A mu A, basically maximum of mu AX and minimum of mu AX mu BY. So first to find minimum of mu AX and mu BY and 1 minus mu X, then take the maximum value. Boolean fuzzy rule. So that is if BF AB is 1 minus A or B. Then Gauguin's fuzzy rules are GF. So that is equal to 1 if A is less than equal to B and this is equal to B by A if A is greater than B. So let's try to understand these things by some example. Example is if X is A, then Y is B, else Y is C. So just like that, if I have time, I will go to shopping, else I will go to home. So this type of statement we face in our everyday life. So here the relation is equivalent to R A cross B union A cross C. We can define it by any operator. So we are try to understand the simply relation we are finding. So first A and B are fuzzy sets. So we'll take the relations. We find Cartesian product. First we find the Cartesian product A cross B, then A cross C, then we take the maximum value. So here we are define X universe of discourse A B C D Y 1 2 3 4. A is a fuzzy set with A 0.0, B 0.8, C 0.6, D 1.0, B 1 0.2, 2 1.0, 3 0.8, 4 0.0, C 10, 2 0.4, 3 1.0, 4 0.8. So first find A cross B. You know in the row A, B, C, D, in the column 1, 2, 3, 4. So first take row A. So A with 1, 0.0, 0.2 minimum is 0. A and 2 0.0 minimum, here 0.0, here 0.0. Now B 0.2, 0.8, 0.8, 0.0, C 0.2, 0.6, 0.6, 0.0, D 0.2, 1.0, So A complement is A 1, B 0.2, C 0.4, D 0. So A1, so minimum value with C is 0, B, so minimum value with A, B, C, D. So A1, 1 and 0 is 0, 1 and 0.4 is 0.4, here is 1, here is 0.8, here is 0, here is 0.2, 0.2, 0.2, C is 0, then here 0.4, so here is the minimum value with C, so here is 0, 0.4, 0.4, 0.4, D, everything is 0. So we got A cross B, we got A cross C. Now find the maximum value. So 0, 0, maximum value 0, 0.2, 0.4, 0.4, 0 and 1, 1, 0.8, 0, 0.8. So in this way we will find the R. So this is the example of if X is A, then Y is B. Now try to understand the next example. Another example. So example is that if X is A, then Y is B, else it is not given. So with the implication of Jadhav-Maxwell rule can be written as RMF is A cross B union A cross Y, where Y is the universe of discourse with membership values for all y is 1, that is mu y 1 equal to 1 for all y. So here the set y can be written as the universe y is 1 2 3 4, so that can be written as 1 1. Every membership values are 1, 3 1, 4 1. So R is A cross B union A complement cross Y. So here X universe discourse Y A B C D Y 1 2 3 4. So A fuzzy set A 0.0, B 0.8, C 0.6, D 1.0, B 1.02, 2.10, 3 0.8, 4 0. So now find A cross B. So row is A B C D, column 1 2 3 4. So row is 1. So 1 with 1 minimum 0.0, 0.0, here also 0.0, here also 0.0. Now B 0.8, 0.2, minimum is 0.2. So it B 0.8 and 0.2, minimum 0.2, here minimum 0.8, here minimum 0.8, here minimum is 0, here minimum is 0.2, 0.6, 0.60, D is 0.2, 1.0, 0.80. So you got A cross. Now we need to find A complement Y. So Y we have already defined. Now define A complement, which is A1, B 0.2, C 0.4, D 0. So now A cross Y. So with A1, so everything will be 1. So A, B, C, D, 1, 2, 3, 4. So A, everything is 1. Now 0.2, everything is 0.2. Then C, everything is 0.4. And D. Now we need to take the maximum value of A cross B union A cross Y. So we need to take the of A cross B and A cross Y. So find the maximum value. So 1 and 0 is the 1, then 1, 1, the 0.2, then 0.8, then 0.8, then 0.2, then 0.4, 0.6, 0.6, 0.4, then 0.2, then 1, then 0.8, then 0. This is the value of the example. If x is A, then y is B. Now in conclusion, we can say that today we have learned fuzzy multi-valued logic. We have learned fuzzy implication. So in the questions, so you can solve one questions like you write truth value of AB. So take 0, 0, 0, then you take 0.4, 0, you can take any value. So let 0.4, then value 1, 1, 1, B 0, 0.4, 1, 0, 0.4, 1, 0, 0.4, 1. Find A and B, A or B, not A imply B, and A equal to B. So complete the table for these truth value. So this is the question for today, and these are the references for today's class. Thank you.